I have an idea. And the idea is that there are all sorts of YouTube channels that do math, and there are all sorts of YouTube videos that do like DIY home projects. But often it seems that the YouTube videos that do math, it's supposed to be like a lecture. Which, okay, if you want to learn math, that's great. But if you're just like cruising around, like, and maybe you would look at someone building a cool trebuchet or something, maybe you would also watch someone do some sort of cool problem. So my idea for this channel is that you all are gonna watch me do some neat problems, and maybe it'll be enjoyable. So the first problem that I'm gonna do is a classic, and I think it's pretty neat. It's called. I want white. The ladder problem. And the idea is pretty simple. You have a corridor which looks something like this with a corner in it, and you're trying to get a ladder around this corner. So maybe you look like this. You're holding the ladder like this, and you're trying to move it around the corner. And we want to find out the largest ladder that can fit around the corner. Okay, so the first step is we gotta start putting numbers and symbols onto this problem. And in order to do that, we have to define mathematically what the largest ladder that can fit around this corner is. And to do that, we say that at each angle theta, there's some largest ladder that can fit at this angle. And if a ladder can fit at every angle theta, then you can get it around the corner. So what we need to do is find the angle theta for which this ladder fit is minimal. Okay, so now we have a minimization problem. And this we know how to do with calculus. But before we can do calculus, we need to get some function of the length of this ladder in terms of theta. So let's get to work with some trigonometry. Okay, we see these two are parallel lines. So these two are parallel lines. So this angle is the same as this angle. And we're going to say that we know the width of the corridor. And so now we can use trigonometry to get these lengths, which I'm going to call L1 and L2 and L1. On this side, we have opposite over hypotenuse, and that's sine. So sine theta equals A over L1. On this side, we have adjacent over hypotenuse, and that's cosine. So cosine theta equals B over L2. And now we can solve for L1 and L2. But before we do that, this is sort of a trick of the trade that saves time. You just, instead of sine theta, you just have S, and instead of cosine theta, you just have C. And this is great. So L1 equals A over S, L2 equals B over C, and then L, the overarching thing, equals A over S plus B over C. So now S is a function of theta, C is a function of theta, so now L is a function of theta, and now we need to minimize L. We want to find the minimum of L. In order to do that, we take the derivative and set it to 0. This allows us to find the point which is at the bottom of the curve, because you can see as a function of theta, like for small theta, L is going to be quite large, and then for theta close to pi over 2, L is also going to be pretty large. So L is basically going to look like this, and once we find this point, we found the theta for which L is minimum, and then we can find the minimum of L. Okay, so let's take the derivative. dl d theta equals negative A over S squared. This is just the chain rule, times C, because that's sine and cosine. And now this is minus B over C squared again, negative S. So now we put these both over the same denominator, and we get A times C cubed plus B times S cubed for S squared C squared. And remember, we're looking for the point at which this is 0, so we're going to set this to 0. And from this we get A C cubed equals B S cubed. From here we just get A over B equals S cubed over C cubed. Okay, and now going on from here, we can do A to the 1 over 3 over B to the 1 over 3 equals S over C. And this is sine theta over cosine theta, so this is tan theta. Now, we could use this to get S equals sine of tan inverse of A 1 over 3 for B 1 over 3, but I can never remember formulas for the inverse trigonometric identities. Like, there's some formula, but I can never remember. What helps is to draw the triangle. So we have theta here, and then tan theta being A to the 1/3 over B to the 1/3 means that there's a triangle with A to the 1/3 as the opposite side and B to the 1/3 as the adjacent side. And then the hypotenuse from the Pythagorean theorem is A to the 2/3 plus B to the 2/3. So now we can read what sine and cosine are off of this. S is opposite over adjacent, A to the 1/3 over, well, let's just call this H. And C is 1/3 over H. And now finally, we get to plug in our formula for L, which is L equals A over S plus B over C. So A times H over to the 1/3 plus B times H over B to, oh, that should be a B. And now we can put this, we can cancel out, so we get a to the 2 over thirds plus b to the 2 over thirds times h. And now remember, h is the square root of this. So the end result is that a to the 2 thirds plus b to the 2 thirds to the 3 over 2. And now, this is kind of why I wanted to do this problem, because what a weird answer. You never see like anything raised to the 2 over 3. And just the fact that you have this sort of like weirdly symmetric answer, I think is pretty cool. And that's really all I wanted to show you for today. Hopefully I'm going to be doing more videos like this, but we'll see. So stay posted.